2.3 Graphs of equations of lines. What is standard form and how do I graph from it? Standard form is funny because it's actually the one that's not standard. It is ax plus by equals c. So that's what we're going to call standard form, but really the different places consider different parts of that to be standard. Usually a is positive, but sometimes that's not a qualification. Sometimes c is on the other side. But basically, something that looks sort of like this, how are we going to get something useful out of it to graph? Well, one thing we can do is, you'll hear it referred to around here. This is not a out there in the math world things. You'll hear it referred to around here as cover up, cover up. That was part of the La Sierra tradition when I got here. And it works because what happens is if I have something like this, 3x plus 2y equals 12, and I want to graph that, it's what standard form is good for is graphing using the x and y intercepts. And so if you think about, we've been talking a lot about y-intercepts, so let's do the y-intercept over here, and then we'll do the x-intercept over here. So we're going to get the x and the y-intercept out of here. And so the y-intercept, well, we know every y-intercept is 0 something. So how can we get that? Well, we can go through the work and plug in 0 and then get 0, which gives me 2y equals 12, which gives me y is 6. Well, that's good. So now we know that my y-intercept is 0, 6. Okay, so if every time I find my y-intercept I'm going to plug in a 0 for x, why not just start here? And so you see, you can really just sort of cover the rest of this up. You really don't need it, right? So I don't know how you're going to represent that on your notes, but just picture me putting my thumb over the 3x when I want the y-intercept. Well, then when I want the x-intercept, I'm going to do something similar, but this time we know that every x-intercept has a 0 in the y position. So this time we're going to plug the 0 in for the y. And so we're going to get 3x plus 0 equals 12. Well, that's just 3x equals 12. And so x equals 4. Well, if we do that every time, we realize, and let's finish this part up here, we have 4, 0. If we realize that every time we do that, we're going to get to here. Again, we don't really need this part when we're finding the x-intercept. So we can just cut to the chase and cover up what we don't need. So we said that graphing this gets us the x and y intercepts. So we've got the y-intercept is positive 6. 1, 2, 3, 4, 5, 6. And the y-intercept is positive 4. And so this is where you really need a straight edge because you can't count. So you use your ID card, use a ruler, use a protractor, bottom of a protractor. And so again, what I want you to note on here is what you use to graph it. You use this time the x and the y-intercept, and if I see that, I'll know you graphed it from the standard form. Write the equation somewhere on the graph for me, and there you go. Beautiful. This time let's do 4x minus y equals 4. So instead of going through that work, I'm just going to cut to the chase on this one. And so for my y-intercept, I'm going to plug the 0 in for x, but I'm not going to actually do that part of the math. I'm going to cut right to, I've covered up the 4x, all I have left is the negative y. Now, some of you are prone to forget that negative, so be really careful. How do I get this alone? I'm actually going to show the math. How do I get this alone? Well, it's a negative y. Hopefully you know you can just change the signs, but the reason it works is, that's a negative 1. So negative 1 divided by negative 1 is positive 1. So I get y is not 4, but negative 4. So the point that I'm going to graph is 0, negative 4. Then for my x-intercept, I'm going to cover up the y term. So I've got 4x equals 4, x equals 1, and so my x-intercept is 1, 0. So I've got 2 points. You only need 2 points to make a line. I like to do 3 points when we're doing graphing by tables. Okay, my y-intercept is negative 4. My x-intercept is 1. And so not very easy to connect on this. There we go, not bad. Okay, and because I can recognize just by looking at this as a slope of 4, it's a little easier for me to get this going in the right spot. Again, with a straight edge, much more accurate. But our intercepts, we want to make sure we label. And give me the label on here. So why do I like slope-intercept form better? Well, you'll notice this graph has a positive slope, but there's no way really to tell that from the equation without doing the math and actually putting it in slope-intercept form in your head. And if you think back about the last graph, everything was positive in the equation, but the slope was negative. So you can't get that mental picture the way you can with, to me, with slope-intercept. So that's why I like slope-intercept form a little better. So that's it. Standard form, know what it looks like, and how do I graph from it? It's good for graphing the intercepts.